Hello, my name is Ed Blundahl, and I'm doing another video on physics topics. And this one today is actually a few different topics that are related. So we're going to start off with the velocity addition equation, which is actually a simple idea. Most high school physics students learn this in their text, but there are aspects of it that need to be talked about as they fit in with more general subjects. And you can see where I'm pointing with this, that this velocity addition equation has its own problems. So, but before I begin, what I would like to say, I have a sort of a little statement and then some other things to say, but I just want to make a statement just to let everybody know where we are in this situation. So, for background, this is the 7th video that I made for YouTube so far. So, we will get into others later on. You should know that the reason I'm doing these videos is that I did try to publish my papers in the standard practice of sending them in to be looked at in refereed journals, but in truth my papers were just all blocked from even being considered. And some of it I think they just don't understand, I'm sure. Some of it they don't want to understand, and some of it they just don't want. So that's why I'm doing these videos, to get them out so people can understand what I'm talking about and talking about them with others. I don't mind doing the videos. They're actually more fun than just sitting behind a computer and just writing a bunch of text and whatnot. Most of my videos, like this one on the velocity addition equation, is actually written up originally as a paper, but since everything is blocked that I try to do within the scientific community, it comes out as a video, and we can go from there. I also want to stress this, that all the ideas and conclusions that come of my videos, all of them, are mine alone, for I did not seek any assistance from any individual or group, and nor would I ever accept any help from a group or people. Working with somebody else would simply slow me down, and besides, the most important part, no one thinks like me. So, which is why they don't like what I'm saying, right? Think different, you run into problems. Doesn't mean my science is wrong, they just don't like it. So that's quite a big difference. So anyway, let's go on with the velocity addition equation. And like I said, it is usually found in high school physics texts. And I'm not going to derive it here because I just don't have a lot of space with doing the whiteboards. But you can, it's really developed from the Lorentz Factor, which you know, also in high school text. The Lorentz Transformation, also in high school text, right? And you do a smattering of calculus, and then you can get the velocity addition equation. It's rather quite simple, and there's not a lot to it in deriving it, but at this point I'm not going to go through that. You know, here's an interesting question. Basically, the velocity addition equation is set up to limit the speed of any two objects, the addition of speeds of any two objects within space, right? So the question comes, at what speed does classical mechanics end and relativistic physics begin? In other words, I just draw a little line there, right? I mean, you can start at 0, and then you can work your way up to, you know, half the speed of light. Then you can go on the speed of light, and then you can go on from there. You know, but at what speed does classical mechanics stop, right? Newton mechanics, whatever it's doing, and relativistic physics of Mr. Einstein begin? I don't think it's that easy a question. I mean, people just pop down, you know, the equation and think they've solved something without really thinking about it. It's strictly mechanical in nature, and that's usually always a bad sign, right? I mean, if you can't think, too many people just do the math and say, there it is, and they never think what's behind it, or what is it all about, or what does it entail, right? Which I like to do. You have over here the, right here, the velocity addition equation, right? And V sub r is simply the relativistic velocity. V prime over here is simply the base, or I should say the velocity with respect to the base. I'll get that in a second. V sub b is the velocity of the base, and then you have 1 and then a repeat that goes over again. So you have the total relative velocity, V sub r, and you have the other velocities. So it could be a situation like, the base could be like a spacecraft, right? And the V prime could be like a projectile shot from the spacecraft. Or, I mean, you could bring it down into mechanical, classical physics. You know, one is just a truck moving and somebody is shooting an arrow from the back of the truck. Or, I mean, there's all kinds of combinations you can use, but usually they use it at a higher velocity, right? So that's, I mean, that's what it is. But what this, you know, Galilean transformation, and that's just the simple aspect, which is velocity sub g, Galilean, is equal to what? Is equal to the v prime, which is the velocity with respect to the base, plus vb, the velocity of the base. So, you know, the same basic idea, except when you, of course, if you put in the information here, right, like an example 1 over here, then you get the, if you let VB equal 0.8 c, so that's like the spaceship going at 80% the speed of light. And then you have the velocity with respect to the base, which is like the projectile, and that's going 70%, 0.7 c, right? And then you put them together, right, in the velocity, where is it down here? It comes out to 0.96, right? So if you put those numbers, 0.8 for velocity of the base, 0.7 for the velocity of the projectile, you end up with the velocity of relativistic velocity is simply 0.96 c, right? Well, if you go back and you look at what this would be, the Galilean transformation, right, that would be 0.7 c plus 0.8 c, and that's going to give you what? It's going to give you 1.5 c. So the Galilean transformation gives you 1.5 c, and the velocity addition equation gives you 0.96 c. It doesn't mean it's right. It just means the math is set up to give you a solution that the addition of velocities is always less than the speed of light. That's it, right? That's why I went back to this. You know, at what point does classical mechanics end and relativistic physics begin? It's not so clean cut, right? And is this right? We'll talk about it later. So, you know, just plugging in the numbers and this is what you get. But you should also know something about what's going on here, right? You know, if you have energy within the system, like a velocity energy, then you have 1.5 c for the Galilean transformation, 0.96 c for the relativistic velocity, and so you have a loss of 0.54 units. In other words, if you're in a system and it's going fast, what's going to happen is you have to curtail that additional velocities to less than c. What happens to all that? It's just like, right? It's an artificial constraint set up using magic so that nothing can go faster than the speed of light. In other words, and that's what Albert Einstein said, right? You can't have a velocity going faster than the speed of light in space. It is impossible. I would say that's a good premise to question, because I don't agree with it, right? So if you look at the 1.5 c minus 0.96 c, you end up with a loss of 0.54 units of velocity, and if you put a mass to that, which I did, you end up with even something more. So here you can see, right, kinetic energy of 1.5, kinetic energy of 0.96. Just use the math, scale it to 1 so it drops out. You do the math, you end up with 0.7 c, and you end up with 1.5, I'm sorry, yeah, in 1.5 c, 0.46 J, I'm sorry, J is the joules. This is pedagogical anyway. But, so let's take it again. Kinetic energy 1.5, kinetic energy of relativistic physics 0.96. You put it over here, it's 1.125 joules for the kinetic energy of 1.5, 0.96 with the kinetic energy, relativistic kinetic energy, and you end up with a loss, right, an energy loss of 0.665 joules. You can put in mass. It's not going to change the basic qualification of what happens here. So not only are you losing velocity, you're losing energy within the system by using this. Well, that doesn't make any sense, right? I mean, it's curtailing it to a point where you have a major energy loss. And the question is, exactly a rocket going at, something to think about, a rocket going at 0.8 c and then shoots a projectile at 0.7 c, but it can only go 0.8